Thank you for the introduction, Stefano. I'm going to talk about the window view assessment framework today. Before getting into the framework, I'd like to share our research findings on the impact of the view in workplace setting. So we recruited 86 participants at the Climatic Chamber, UC Berkeley, where we have a real window, and we also controlled environmental aspects such as light level and temperature, like we have a earlier discussion in the first panel. And in slightly warm conditions, which is 82 Fahrenheit, which is equivalent to 28 Celsius, with windows, people felt cooler, which is really interesting findings we had because it has potential energy saving benefits. And also we found that like people felt happier, better emotion, and more focused, which could be having like really good implication for improved well-being and productivity in workplace. But this research is being done in our chamber, has like the three views. And of course, our research team was wondering about, what if we had a different views? Did our finding could be different? So we were thinking about, what's the important characteristic within the window view and how we can quantify that. That was the initial point of our research and then development of this view framework. So let me ask one question. Imagine that this is your window views in your workplace. Where would you prefer to work? The answer is pretty obvious. Why? It's obvious why everyone want to have the image on your right, because it's actually a really difficult question because it's a combination of all different factors, including what you see through the window and how big and how clear the window is quite different in these studies. So, however, we found that there's no design framework that considers all these factors that I mentioned out there. So our research team reviewed over 100 building standards and green certification systems, including including like ASHRAE and IS or even European guidelines, and also LEED and WELL. And also we reviewed scientific research papers, ranges from like architecture, urban planning, landscape, and environmental psychology, even vision science. And we combined all those recommendations from this literature and then into three primary variables that define view quality. And based on our industry advisory workshop conducted by our research center, we were able to develop the view quality index, which is VQI. So very first thing that I need to mention is the primary variables that we define based on the literature review. So we also consider the design process of the building. So imagine that this simplified box is a building. The very first variable will be the content. It's about what you see through the building. So it's directly related to the site planning and building massing of the design process. And the second variable is view access, which is about how much you have within your workstation or your position within the building. So that's directly related to the facade design and also floor layout. And then the third variable is about the view clarity, which Yasin presented a lot. It's about how clearly you can see through the window. So it's about directly related to facade material and control. All these three factors matters so that we can actually get the overall view quality. So defining the three primary variables for view quality is the first kind and one of the major contribution of this framework. In the following slides, I will summarize design criteria for each variable and then the research gap for each variables found in the literature. So the first variable is content. William and Michael briefly mentioned about it, and then it's some of the visual features seen in a window view. There are quite a lot of different criteria, and then we found that like majority is falling into these four different categories, which is the first one is like nature versus urban features. Of course, people prefer to see nature features including water body or greenery over the urban fabric. But there's some exception because the urban features can be also be preferable if it has like a landmarks like such as Statue of Liberty or Eiffel Tower, or it's a really pretty artifacts. And then the horizontal stratification and content distance is another design criteria for the content, but Michael already explained it, so I will go by it. And the last design criteria is dynamic features, which is movement, which includes peoples on the street or water features or even traffic flow. However, this is most understudied area within the view content area, so the scale and duration and frequency of the dynamic features should be further discussed or studied. So the next primary variable is the view access. It's a metric quantifying how much the window view an occupant can see through from a particular location within a space. There are multiple ways how standards account for the view access, but it is usually based on geometric relationship between occupants and their window views. So these are some examples of metrics for view access we found in literature. The view angle is the angle between the occupants and then the vertical or horizontal window frame. And European guidelines and lead version 4 adopted this metrics. And also we found this distance from a window and window to wall ratio is also being used in BREEAM or partially in LEED. Surprisingly, we found a lot of green certification system uses the spatial assessment method for view access, which is the space that can provide a visual contact with the window or not. But in their requirement, there's no requirement for what's the visual contact means, meaning it could be really small, or maybe it could be really bad window view. They don't care. It's more like if they have a visual contact, certain level of it with the window. So it's a little bit problematic. And in simulations, we also found that some researchers uses the rays cast from one viewpoint and use it to analyze, what kind of view access they have. But all these things are great, but we found that none of the metrics actually take account all these different geometric aspects of the between occupant and then the window views. And usually it's not based on the threshold, or metrics are not based on human subject tests. The third variable is view clarity. It's about the metrics assessing how clearly the visual content in a view can be seen by the occupants. So it accounts for the visual obstruction present at the window before, after, even inside of the glazing layer. And then we found that it is most understudied area among the view variables. So the design criteria for this, we found the first one is a window design, especially placing of the glazing support like mullions can actually obstruct the view, especially when you're in an office setting where the workstation is already fixed and the view angle is fixed for the occupants. It could be a problematic. And also glazing and shading materials can also block and distort the window views as shown in the image. A building in Vancouver, you can see that even though the designer designed the building maximize the view connection, having a maximized glass area, often people need to draw the lines. So balance between visual and thermal comfort and this discomfort and window view should be considered. Also, differentiate material can yield different view clarity as Yasin's presentation. And also we give out some example here where we have two different fabric shade has the same solar transmittance value, but since it has different openness factor and other optical properties, the conveyance of the view is quite different for these two fabric shade. And then another design criterion for view clarity is about compositional and temporal attributes, which is most understudied, but also really complex. Because as you can see in the building in Vancouver, you can see that usually the shade is operated partially, not fully. So we need to understand what's the compositional attributes contribute to the view quality and how people react to it, and how long the minimum acceptable levels should be kept in terms of the course of the year or day of the time was really important. And also that's an important question to the daylight folks as well. So we found that this view clarity area is like really important when we think about the temporal attributes, and it should be considered with the climate-based daylight matrix. So far, I explained the three variables and the framework. Now I'm introducing an index that describes the conceptual basis of view quality, which is VQI. It has a basic equation format. So all three variables, contents, access, and clarity plays a role for view quality. And if one of the variable is low, even if the other two are high, the result view quality will be low. To reflect this relationship among this variable, we proposed the view quality index to have a product relationship between these three variables. These images are actually explain the equation further. So the first image, if the view content is low quality, like nearby brick wall, the occupant would not be satisfied even if the high level of the view access and clarity. By the same token, if you look at the second image, if the occupant is too far away from the window, which is like insufficient view access, even though they have like good view content and clarity, the overall view quality is not going to be great. And then similarly, the last image is actually showing the view that constantly requires a shading device to protect occupants from the glare, achieves little view clarity, and therefore insufficient view quality. So this figure shows how VQI can be calculated across different window views using four labels: insufficient, sufficient, and good and excellent. It's also following the European guidelines for different labels. And as the green bar shows, the VQI range is 0 to 1. And I forgot to mention about this previous slides, we assign 0 for when each variable has lower than minimum acceptable range quality, and 0.5 for minimum acceptable range, and then 1 for saturation range. So you can see that if one of the variable is below minimum acceptable range, we assign 0, which is all three images I explained in the previous slides, which automatically gets 0 for VQI because it's product relationship. And then the overall view qualities are rated as a high. I mean, like content and access and clarity are all high. What you can see on the very left-hand image, VQI will be 1 and it's gonna be excellent. And then when you see the image on the middle, it's the view that all the access, content, and clarity, all these three variables have just minimum acceptable range, then it's gonna achieve like 0.125 as a VQI. So it's gonna be sufficient view quality index. So these are what we developed. And then I'd like to summarize what's the contribution of this framework a little bit. So this framework provides the design recommendations and view quality index model, as I just described briefly. And it was already accessed and discussed by over 150 architects and practitioners. And it's recently accepted for peer review journal Lucas, which is one of the major lighting journal in the field. So with this framework, architect can design the built environment with having quality views based on the balanced window design. And those quality views can contribute to improve comfort, well-being, and health. And this also can be tied with the productivity issue that I kind of brought up earlier in my presentation. And then the research point of view, again, it was the very first holistic design framework that bridged the gap between research and design, and also bridged the gap between like building standard, green certification system, and scientific literatures. And all these are all built upon the comprehensive literature. So that was what I prepared for today. And actually it's like a really like comprehensive paper, and you can click the link to see more. But yeah, that's all. Then I'd like to have some questions later. Thank you.